Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 770. Please turn to it. Page number 770. And today is our lesson number 92. Let's take a look at it. It says the sum of two numbers that differ by 1 is t. So we are told that there are two numbers and their difference is 1. And that sum they're calling it t. I presume t for total. In terms of t, what's the value of the greater of the two numbers? As you can see, this is an algebraic question. This is an algebra word problem, and therefore, as I always tell you, in this exam, whenever you come across an algebra problem, there are two ways you can go about it. One is what I call the traditional way, the conventional way, the orthodox way, the geeky way, the classical way, the nerdy way, the academic way, of course the algebraic way. And the other one is the quick and dirty way. And the quick and dirty way, what you do is you plug in numbers for the variable, you make up numbers for the variables, and you convert this algebra problem into a very simple, very straightforward arithmetic problem. Once you have your answer, you plug in the same values for the variables that you plugged in the problem, in the answer choices, and see which one agrees with the punchline that you came up with. That's all. So which way would you like to do first? Would you like to solve this question the algebraic way first, or would you like me to solve it the non-classical way first? Let's do the non-classical way first, shall we? Let's plug in numbers. Let's plug in numbers. Make up any numbers that you like, as long as they meet the conditions that are stated in the problem. Here we are told that first of all they have to add up to t. Actually, they do not say they have to add up to any particular number. So you could actually make up any two numbers as long as their difference is 1. I'm going to make up 3 and 4. Plug in 3 and 4. As you can see, 3 and 4, they differ by 1. They differ by 1. It doesn't matter whether it's 3 and 4 or 4 and 3. It makes no difference. Only thing that matters is that their difference is 1. Difference of 5 and 6 is 1, and so is the difference between 6 and 5. And we are told that their sum is t. So they're calling the sum t. So in our case, t would be 7. Remember that. The question is, what is the value of the greater of the two numbers? The greater of the two number is 4. I put a box around it. The box tells me, the box signifies that this is my punchline. As soon as you find the punchline, put a box around it. That's it. We're done. That's it. That's the answer, 4. That's it. We're done. All we have to do is go to our answer choices. Wherever we see t, we replace it with 7 until we come upon a quantity that gives us our punchline. Let's take a look. A says t minus 1 over 2. T minus 1 would be 6. 6 over 2. It does not equal 4. That equals 3. We don't want 3, we want 4. Because the question is which one of them is the greater one. They're not asking which one of them. If they were asking which one of them is the smaller one, the answer would have been A. In that case, the answer would have been A. B says t over 2, which is simply 7 over 2, which is just utter rubbish. And C says t plus 1 over 2, well our t is 7, 7 plus 1 over 2 is 8 over 2, and 8 over 2 is 4, voila, what do you know? That's our punchline. The answer is C. The answer is C. You can try out all the others, all the remaining two answer choices, and you will see that they would not give us what we're looking for. We're looking for 4. So this is one way of doing it. Another way to do the same exact problem with the algebra is what you will see in a second. But this is it. We are done. The answer is C. The answer is C. Let's do the algebraic way now. Algebraic way is only for those people, for those of you who are into masochism. Learn that word, shall we? The adjective would be masochistic. A masochistic person is somebody who enjoys inflicting pain on himself or herself. If you're into masochism, if you want to suffer, then go ahead and by all means do the algebraic way. I wouldn't do it algebraic way in the exam. Why the hell should I? I'm not masochistic. What the hell? We never learned this word. This is impossible. We have never learned this word in our vocabulary lessons. How is that possible? How did I miss it? In that case, it makes me wonder if I spell it correctly. The word is masochism, and I'm looking at the list of vocabulary words in M in my thing here, in the list of words, and it doesn't appear here. We have not learned it. And in case you're wondering what I'm babbling about, in addition to this math video that you're watching, if you're interested in improving your vocabulary, you can go to my channel and look for the vocabulary videos to help you get a better score in the reading portion of the exam. There are also videos that will help you with the grammar questions of the exam, which is the writing part. Anyway, the word is masochistic, which means a person who enjoys inflicting pain on himself or herself. So let's do the masochistic way, shall we? And this is how it goes. We have one number, let's call it x. Let's call it x. And since they differ by 1, since the difference is 1, then if first number is x, we cannot go around calling the other number y. You see what you have to understand? Now listen, if I have to explain all this thing, that means you're not cut out for algebra. You cannot go around calling one number x and another number y, because algebra is a language. And when you signify, when you designate some number by x and the other one for y, with y, what you're telling me is that this is one number right here, this is another one number right here, and they have absolutely nothing to do with each other. They are not related at all. Which in this case is not true. We know that if one is x, the other one has to be one more than x, because their difference is 1. Therefore, we're not going to go around calling it y. It one has to be 1 more than x. And their sum equals t, which tells us that 2x plus 1 equals t. Let's solve for x. So 2x equals t minus 1. Divide both sides by 2 and we get t minus 1 over 2. But this is not the answer. This is a sucker answer. This is the answer that will give us a, which is this one of the that's the smaller number. X is the smaller number. We need to find the large number, which is x plus 1. This is the large number because this is one more than that. So now we have to find this point in terms of x. So it's going to be x plus 1, which equals t minus 1. Let's do it right here. X plus 1 would be just 1 more than that. And therefore x plus 1 would be, we have to find the common denominator here. Is that all we have to do here? This is unreal. And minus 1, and this will become t minus 1. And then with the common denominator, when we do, it becomes 2 over 2. And that's how we get negative 1 and a positive 2. It will give us t plus 1 over 2. Which is what we found the answer to be when we did it the non-classical way. Let's do number 8, shall we? Number 8. Just give me 1 second. This makes me wonder why I could have sworn that we had learned this word before. No. Anyway, number 8. Just so you know, if you look up the word masochism in the dictionary, sometimes some dictionaries have a tendency of giving this meaning of this word in a very narrow context. It has a very broad meaning, which simply means to enjoy having, having pain. That's all it means. That's it. Anything else that you find in the text, that's narrowing it down. It doesn't have to be in a certain context. It doesn't have to be in a certain situation. And you will see what I mean by certain situation and certain context when you look in the dictionary, but it does not need to be that. It has a very broad definition, which simply means to enjoy pain. Number 8. The table above shows how many students in the class of 12 had 0, 1, 2 or 3 siblings. Alright, so we have, here is the number of siblings. And here is the number of students. So we are told that in our class there are 3 kids there are 3 kids who have no siblings. They are the only child. They are the only child. They are the only children in their family, in their respective family. Yes. It's a strange sentence. No, they are the only child. They are the only child in their respective family. Yes, they are the only child. There are 6 students. There are 6 students who have 1 sibling. There are 2 students who have 2 siblings, and there is 1 student in the class who actually has 3 siblings. His parents were very busy. Later, a new student joined the class, and the average number of siblings per student became equal to the median of the sibling. How many siblings did the new student have? Alright, this is interesting. Let's read one more time. Later, a new student joined the class, and the average number of siblings per student became equal to the median number of siblings per student. How many siblings did the new students have? Alright. Well, let's find out what the median is here. The median here would be, there are 3 students with 0 siblings. So 0, 0, 0. There are 6 students with 1 sibling. 1, 2, 3, 4, 5, and 6. There are 2 students with 2 siblings, and there is 1 student with 3. And there are how many kids here? Of course, they tell us there are 12. 2, 4, 6, 8, 10, and 12. What's going to be the median? Because there are even number of numbers, typically when we want to find the median, half of them fall to the left of it, half fall to the right of it, and the number in the middle is the median. Once they are arranged in either ascending order or descending order. Here we have even number of numbers. Therefore, the median here is going to be the average of 5th and 6th. Average of 5th and 6th. 1, 2, 3, 4, 5, and then this is 6th. The average of 1 and 1 is just 1, and therefore the median here is 1, which means the new average also needs to be 1. But keep in mind that once another child joins, then we need to divide the total number of children, total number of siblings rather. We need to divide the total number of siblings of all of these 13 children by 13, because the one child joins in, now the class size is 13. So let's find out how many children we have, how many siblings we have so far. Let's do it out here. Let's do it out here. 3 kids have 0 siblings, so that's a 0. 6 kids have 1 sibling, so that's 6 siblings so far. There are 2 students who have 2 siblings each, so those are 4 siblings so far. And there is 1 student which has, did I say which has? Who has? Who has? I don't want to digress right now between which and who. Let's make a note here. Which and who. I'll do that at the end. Who has 3 siblings? 6 plus 4 is 10, and 13. Oh, what do you know? There are 13 siblings so far before the new student joined the class. Okay, keep listening. This is a tricky question. Before the new student joins the class already had 13 siblings. And now we know that the average, we are told, is equal to the median. But the median is 1. Since the median is 1, average needs to be 1. And how can we make an average to be 1 if there are 13 children? If there are 13 children, then 13 siblings, 13 siblings divided by 13 students will give us the average of 1. But there are 13 siblings already before the new kids join. That tells us that the new child who joined the class has no sibling. The new child has no sibling. The answer is A. The answer is A. And when the new child joins, this number is going to change from a 3 to a 4. And total number of siblings are still going to be 13. Total number of kids in the class are going to be 13, and 13 divided by 13 is 1, which is equal to our median. Oh, that was a tricky one. Very quickly before I actually close the video, because I brought it on, I have to finish it now. What's the difference between which and who? Who obviously is used for, in grammar, grammarian will speak in terms of animated object and inanimated object. Animated means to have life, to be able to move around, hence the computer animation. An animated object, your cat, your dog, is an animated object. So is your mom and dad, and so are you. We are animated objects as far as the grammar is concerned. Inanimated object means it has no life. So when we're talking about inanimated objects, we refer to the object as which. Do you understand? The glass which you put on the table the other day there is missing. The boy who you saw the other day, not the boy which you saw the other day. Sometimes people say that, but it's wrong. You're referring to a boy. It's an animated object. It has to be referred to with who, not which. I made a mistake when I was speaking. Do you understand? Anyway, so since I had to correct my mistake, I figured I will get it out of my system properly. And I have gotten it out of my system, believe me. I feel much better. I will see you tomorrow, okay? Bye now.